This is question 18 from the Unit 4 review for MAC 1105. Use properties of logarithms to condense the logarithmic expression. Write the expression as a single logarithm whose coefficient is 1. That's the directions for number 18. All right, so when I look at this, I can group these two together because I know addition of logs becomes multiplication, and I also can group these two together because they're both minus. So what I'm going to do first is rewrite this. So I'm going to do log x plus log of x squared minus 64. And I'm going to take the GCF of a negative 1 out. So negative log 3 plus log of x minus 8. And the reason why I'm doing that is because it'll make it easier for me to write this up. Okay, so these two, because they're added, I can combine them to say log of x times x squared minus 64. And then minus, and then I can combine these two because they're added, log of 3 times x minus 8. Okay, now I'm going to go ahead and do this. So log of x times x minus 8 times x plus 8. This is a difference of perfect squares. That's what x squared minus 64 factors into. And this minus will be division of log of 3 times x minus 8. So I can cancel out the x minus 8s. So I can rewrite this up as log of x times x times x plus 8, which becomes x squared plus 8x over 3. And now I have everything combined together. All right, let's look at question 19. Use the common logarithms or natural logs and a calculator to evaluate to 4 decimal place. You must show work. Your calculator can't handle base 4, so you need to use the change of base formula. Okay, so the change of base formula says I do log base 10 of m over log of the base. Okay? All right, so we just need to figure out what is m and what is b. So m is the 32, so log of 32 divided by log of base, the base is 4. So what I'm going to do is literally do what it says. I click on the log key, I type in 32, I use division, and then I do log key of 4. And I hit enter and I get 2.5. And that's my answer. Solve each exponential equation. Solve using like bases. Give the exact answer. All right, so I see the base over to the left-hand side. I need to write 64 up as the same base. So if I look at 4, 4 squared 16, 4 to the third is 196, which is too big. And hold on one second. Okay, so let me just write this out. 4 to the first is 4. 4 to the second is 16. 4 to the third is 64. There it is. Okay? So we're going to rewrite 64 as 4 to the third. So 4 raised to 2x minus 1 equals 4 to the third. Now my bases are exactly the same, so I can set the exponents equal to each other. So 2x minus 1 equals 3. Putting 1 over to the other side, 2x equals 4. X equals 2 is the answer. Okay, let's look at this next one. Solve each exponential equation, express the exact solution using a natural log, then approximate the answer as a decimal. All right, so since it's telling me to use natural log, I have to use ln. Okay, I cannot write 8 as the same base as 3. So what I have to do is take ln of both sides. So ln of 3, x minus 6, equals ln of 8. All right, I can move the x minus 6 down because I'm in a log. So x minus 6 times ln 3 equals ln 8. Now I want to isolate x. In order to do that, I have to move the ln 3 over to the other side. So this becomes ln of 8 over ln 3. And to finish this up, I'm just going to add 6 to that. So ln of 8 over ln of 3 plus 6. So in your calculator, use parentheses. So parentheses ln of 8 divided by ln of 3, end parentheses, and then add 6. And when I do that, I get x equals 7.8927. It says round to 2 decimal places, so that's a hundredths place. I see there's a 2 behind it, so I'm going to leave it alone. So 7.89 would be my answer. And that's my decimal answer. So 7.89. My exact answer is x equals ln of 8 over ln of 3 plus 6. Okay, thanks for watching that one. That was number 21, and I'm going to start the next video for 22 through 24.